Now, what are the strengths of asymmetric or public key cryptography? The asymmetric nature of public key cryptography allows it a sizable advantage or a significant advantage over symmetric key algorithms. The unique private and public keys provided to each user allow them to conduct secure exchanges of information without first needing to devise some way to secretly swap the keys. This glaring weakness of secret key cryptography or symmetric key cryptography becomes a crucial strength of the public key encryption system. But there are weaknesses in public key encryption also. Keys in the public key cryptography, due to their unique nature, are more computationally costly than their counterparts in a symmetric crypto system. Asymmetric keys must be many times longer than keys in the secret key cryptography in order to boast an equivalent security. Keys in symmetric cryptography are also more vulnerable to brute force attack than in the secret key cryptography. So there are algorithms for public key cryptography that allows attackers to crack private keys faster than a brute force method would require. The widely used and pioneering RSA stands for Rivest, Shamir and Edelman algorithm that leaves it susceptible to attack in less than brute force time. While generating longer keys in other algorithms will usually prevent a brute force attack from succeeding in any meaningful length of time, these computations become more computationally intensive. That means more resources are required. These longer keys can still vary in effectiveness depending upon the computing power available to the attacker. Public key cryptography also has vulnerabilities to attacks such as man in the middle. In this situation, a malicious third party intercepts a public key on its way to one of the parties involved. The third party can then instead pass along his or her own public key with a message claiming to be from the original sender. Then the attacker can use this process at every step of the exchange in order to successfully impersonate each member of the conversation without any other parties having knowledge of this deception. After a bit of cryptography, we move on to fundamentals of networking. Now, I suggest that if you are not aware of the fundamentals of networking, go to Google, learn about ports, protocols, the kind of networks. You can study in depth on this if you are interested in the networking aspect. Also, how routing works, what is a firewall. We will go through all the fundamentals of this in this session. But I would suggest that you do deeper reading to have a strong foundation of what a network is. So, what is a network? It is simply two or more computers connected together or linked together using some form of communication medium. The most common types are LAN and WAN. Most of you would have heard about LAN and WAN. The primary difference between the two is the LAN is generally restricted to a limited area or limited geographical area, whereas WAN covers geographical area. Most WANs are made up of several interconnected or several connected LANs. Then you have intranets and extranet. Intranet is a private LAN designed for use by everyone within the organization. An intranet may consist of an internal email system, a file server, a message board, a print server, maybe one or two website portals which have information about the company news, forms, HR system, and access to intranet's website is generally restricted by the use of a firewall. Extranet is a network that connects people within your organization with people who are outside your organization, like your vendors, consultants, your auditors, all within a secure password-protected network that can be accessed from anywhere. What are the benefits of the network, of having a network? One is information sharing. Authorized users can use computers on the network to access and share information and data. This could include special group projects, database, etc. So you take the example of accounting package. Tally is used where several people in the accounts department can access, update the accounts details, share the account details. Then hardware sharing. One device is connected to the network, such as a printer, scanner can be shared by many users. So one device which is connected to the network. So it can be a scanner, it can be a printer, it can be any other, it can be a SAN, storage area network. It's connected on the network and it can be shared by different users. Take the example of a file server. File server is connected on the network. People can collaborate, share files with each other. Then software sharing. Instead of purchasing and installing software program on each computer, it can be installed on the server itself. All of the users can then access the program from a single location. So it's similar to the example, or it is the same as having Tally installed where all the accounts people can view it. It can be a Microsoft Office suite, or you can say other softwares which require or which is required by different users within the organization. Then collaborative environment. Users can work together on group projects by combining the power and capability of different diverse equipments. But then with great power comes great responsibility also. In the words of Stan Lee, or who is the creator of Spider-Man. The risk of network computing is the security of a computer network is challenged every day by equipment malfunctions. The server may stop working, the printer may stop working, there can be system failures, there can be a hard disk failure, it can be caused by natural disasters, it can be because of not connecting the equipment to an uninterruptible power supply, it can be because of computer hackers. It can also be because of virus or malware attacks. So any of the reason can be a cause for a network downtime. So bigger your network, the more protection mechanisms you have to put to safeguard from different kinds of attacks, different kinds of failures. Then we go on to communication medium. A communication channel is to transfer data from one computer to another, which requires some type of a link through which the data can be transmitted. This link is known as a communication channel. Your RJ45 cables are a communication channel. Your RJ11, which is a telephone cable, is a communication channel. So to send data through the channel requires some type of transmission medium. So your media itself, the cable itself is the media. The channel is within the media, you transmit data, you transmit voice, you transmit video. And this media can be either physical or wireless. Look at physical media. There are different kinds here. Coaxial cable, twisted pair, fiber optics, ISDN lines. The twisted pair cable consists of two independently insulated wires twisted around each other. This is the least expensive kind of cable, the kind that is used in many telephone systems. So I mentioned RJ11. RJ11 is that cable which is used to connect the telephone instrument or the telephone line that comes into your building. Then coaxial cable consists of an insulated center wire grounded by a shield of braided wire. This is your cable, the cable that connects to your set-top box, or which directly used to connect to the television. But this is a little more expensive than the twisted pair. Then you have fiber optic cable, which consists of hundreds of clear fiberglass or plastic fibers or threads, which is the latest or which is the media which is used more frequently nowadays, where the data transmissions are much faster. Then there is a kind called UTP, which is unshielded twisted pair, which is used in your Ethernet cables. Then there is ISDN line, which is a special kind of digital line that transmits and receives information at very high speeds. So the ISDN lines are also more expensive. There are wireless media also, like your microwave system. It transmits data via high frequency radio signals through the atmosphere, through the air. Then there is satellite system, which receives transmitted signal, amplifies them, then retransmits the signal to the appropriate location. Cellular technology, just the ones we use in the mobile phones. It uses an antenna resembling telephone towers to pick up radio signals within a specific area or a cell. That's why it's called a cell tower. Infrared technology, which transmits data as infrared light waves from one device to another, providing a wireless link between PCs and peripherals. Again, what a point to note here is the type selected is determined by the type of the network, size of the network, and the cost that the company is ready to put in. How are the networks categorized? They are classified using three properties: based on the topology, based on protocols used, and based on the architecture. We look at all of this. Topology is nothing but a layout which refers to the way computers and peripherals are configured to form the networks. There are different kinds of topologies for network. The older one was the bus topology, wherein all the computers are linked by a single line of cable. The problem with this was if there is a loose connection or if one computer fails, then all the other computers also used to fail. Then there was ring topology, the second one, where each computer or workstation is connected to two other computers with the entire networking forming a cycle. Here also there was a problem. Then came the star topology, which is widely used now, where multiple computers and peripheral devices are linked to a central computer called a host. So it is like your server and clients. Then you have the hybrid topology, where you combine network layout types to meet the needs of the organization. What is a protocol? Protocol is simply an agreed set of rules and procedures for transmitting data between two or more devices. In simple terms, rules of communication is called a protocol. What a computer can do to communicate is determined by what a protocol is. Now, what are the features determined by the protocol? How the sending device indicates that it has finished sending the message. How the receiving device indicates that it has received the message. And what is the type of error checking that has been done. Again, these are the basics of what a protocol is, or the definition of protocol. You can Google it and find more or have in-depth information about what a protocol is and how they communicate, what are the different kinds of protocol, what are the common protocols. We'll of course go through in the coming slides. Most of the computers use Ethernet, but some may use IBM's token ring protocol. When you see the internet, the major protocol is TCP/IP, Transmission Control Protocol, Internet Protocol. An acronym is Transmission Control Protocol, Internet Protocol for TCP/IP. There are different kinds of protocols, Internet protocols. You have, if you see the OSI layer, which is a 7-layer model, which starts from the physical and goes up to the application. Here, in your internet protocols, several of the protocols sit in different layers of the internet protocol suite. Now, some of the examples are given: File Transfer Protocol, FTP. The first one is Telnet. The second one is File Transfer Protocol. Simple Network Management Protocol. Then Message Transfer Protocol, Hypertext Transfer Protocol. If you notice, all the P's are called protocols. TCP, Transmission Control Protocol. UDP is User Datagram Protocol. IP is Internet Protocol. ARP is Address Resolution Protocol, which is used for converting IP addresses to hardware addresses. ARP. RARP does the reverse. So there are different kinds of protocol used for different purposes. Now HTTP is used for browsing the web. SNMP is for monitoring devices. SMTP is for sending your mails, messages. FTP is for file transfer. Telnet is used to connect to your router, firewall, server, different kinds of devices. ARP is a function where the IP address is converted to a MAC address so that the computer can understand. There are several devices used in networking. Hub is an electronic device with a number of ports which is used in a LAN to link a group of computers. Repeaters, they are also called amplifiers. It's an old implementation because networks were limited to a certain distance. Because of the topology and the media used. Then routers are devices used to ensure that messages are sent to their intended destination. Gateways are hardware or software that allows communication between dissimilar networks. Bridges are hardware and or a software that allows communication between two similar networks. Then you have modulators, demodulators, which are also called modems. The basic purpose of a modem is to convert the digital pulse to an analog pulse and transmit over the wire. Now, this is a simple example of how a modem works. A modem is a device that converts a digital data originating from a terminal to analog signal used by voice communication networks such as the telephone system. At one end, modems convert the digital pulses to audible tones and convert the audio tones back to digital pulses at the other end. So, the word modem stands for modulator, demodulator. We have seen some of the protocols in the Internet Protocol Suite. FTP stands for File Transfer Protocol for uploading, downloading files. SMTP is Simple Mail Transfer Protocol used for transmitting email messages. POP is again used for mails, which allows the recipient to retrieve the messages from a server. Wireless Application Protocol enables wireless devices to access the network using a client-server architecture. And 802.11 is a protocol for wireless LAN technology. So all the basic details we are covering. Now let's see what's a firewall. Firewall is a choke point or something that controls the ingress and egress to and from the network. It is also used for monitoring. It interconnects networks with different trust levels, meaning I allow services of only HTTP to network A, but I will allow the services of FTP and HTTP and SSH to network B. So this imposes restrictions on network services. That means only authorized traffic or only the allowed, what is supposed to come in, what has been configured to come in, only will come in. Then it also has a capability of auditing and controlling the access to the network. It can also implement alarms for abnormal behaviors. So nowadays you have something called a UTM device, Unified Threat Management, which consists of your firewall, your router, your IDS, your IPS, your anti-spam, email gateway. So all this put together into one box. So it is itself immune from penetration and it provides perimeter defense. So basically it provides defense at the edge of your network or the place where your network exits your internal network and goes to the external network. When you take security consideration, what are the important characteristics of a network? That is the degree of locality, media used, and the protocol used. Let's see the three of these. Degree of locality means some networks are very local, meaning it is confined to a specific physical area and where only a small number of users and machines are there, which have a common goal and interest. All work on a Windows system, all use specific software for doing the business, and all reside within the same office premises. So that is a degree of locality. Now, there are other networks which are very non-local. Example, the internet backbone, which consists of several servers hosted at different geographical areas within the world. Many users access it. Many users from different areas, different countries access it. They share the bandwidth. So, degree of locality determines what kind of network is used. Now, if you see an e-commerce site, there are several millions of customers who will be coming, let's say, for subscribing for a book or subscribing a service on the network. The subscribers some may be from India, some may be from Russia, some may be from the US. So they share the bandwidth to access this site, share the bandwidth in the sense through different paths they come in, but the resources they are accessing is same. So the degree of locality determines the type of networks which are used. We have spoken a little bit about media. So some networks are wires, cables or over telephone lines. They can be physically protected. So when you are talking about media, when it comes to wires, when it comes to cables or when it comes to telephone lines, within the organization premises, it can be physically protected. It can be made tamper-proof. But then the wireless technology, we have seen 4 or 5, like your satellite link or other radio links. It is difficult to provide physical protections for these devices. You may be able to protect the device itself, but not the data that it is sending out or receiving. Then the protocol types, TCP/IP is the most used, but it only specifies some common intermediate levels. Other protocol also exists above and below the TCP. In some places, other protocols also replace TCP/IP. And then there are a lot of supporting protocols like the routing protocols, naming protocols, directory protocols, network management protocols. Then you have security protocols, which is IPsec, SSH, SSL. To understand TCP/IP, the three-way handshake, how it establishes a communication from a client to a server,